Hello everyone. For this tutorial video, I'd like to explain how to calculate the center of mass of a 2D object using integrals. The first step is to find the overall mass, which for an irregularly shaped object like this, uses the technique from Calculus 1 of area between two curves. So the upper function minus the lower function integral of that. But we also multiply by the constant of density, because we are assuming, to make our life simpler, that the object has the same density throughout. We next use these two equations for the moments along the x and y axis, or the tendency to rotate around these axes, which may not seem helpful by themselves. But if we were to divide the moment of x over the overall mass and the moment of y over the overall mass, we would get the exact coordinates for the center of mass. Unfortunately, because of how messy the moment formulas are, the coordinate formulas must also be messy. But if we were to simplify it by writing A for area equals the area between the two curves, then we could rewrite the x component as the moment of y times 1 over a, and the y component as the moment of x times 1 over a. We next notice, because the density is the same throughout, it is the same in the numerator and denominator of both coordinate formulas, so as a net result it cancels out. For example, if we wanted to calculate the center of mass of this region, given by y equals 2 times sine of 2x, the x-axis, and the interval from 0 to pi half, we would see by visual estimation what the center of mass is, but we should use the formula to be extra sure. So we do upper function, which is 2 times sine of 2x, minus lower function 0. Anything minus 0 is simply that same function, so we do not write minus 0, and integrate it from 0 to pi half as that is the interval specified, with respect to change in x. We get the indefinite integral as negative cosine of 2x, and plugging in and subtracting the indefinite integral at the point specified, we have 2 as our final answer. We next do the moment of x formula by multiplying this area by x, so we get 2 sine squared of 2x, and similarly we use the formula for the moment of y numerator, and see we can simplify using integration by parts. So now once everything is done, we get pi half for both coordinates, or moments more specifically. We remember that for the coordinates we divide the moments by the mass, so since we found the mass was 2, both of the coordinates are pi over 4 rather than pi over 2. In conclusion, we have definite evidence that the coordinates are pi fourths and pi fourths, even though we might have been able to guess that just by looking at the object. Now that we have figured out how integrals can be used to calculate the center of mass, we can discuss how integrals are applied in probability next. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.